So I wanted to solve a fucking differential equation in QBasic. Namely this one, which I'm sure you're all familiar with. So let's just quickly set up the screen. Height. Okay, so this second order homo whatever equation is of the so-called simple pendulum. So let's just draw it at the center of the screen. And this angle theta, when it's at 0, it is hanging straight down. The pendulum hangs straight down. So it's gonna look like something like this. Let's just make these L equals 50, whatever. L times so because we don't have the letter theta on our keyboard, we'll use A for angle or alpha, and this will then simply be this kind of structure here, and we'll just circle it in the end. Make this a little bigger. And if this is a small value, then it just shifts over to the right like that. Okay. So to solve this fucking differential equation, you might remember that it has a first order approximation solution. That is, when you set sine of theta to theta, you get this fucking solution, which makes sense because theta 0 is your initial condition. So if you hang the pendulum off a certain initial condition and let it go, then the function, the time varying function over time, should have the amplitude of the initial condition so long as there is no air friction, resistance, or damping. So, I mean, all you have, the leap of faith you have to do here is realize that this cosine or sinusoidal function is the solution to this kind of linear first order equation where you pretend this is a constant and this is just theta. So let's give that a shot. Let's call our initial angle A1, and we'll call it pi over 4 for 45 degrees. So then the final, or the time varying, time starts at 0. Time increases with every frame. And our final angle is A1 times cosine G over L, I think. G over L square root. Can slow this down. Maybe keep it at 60 and keep the gravity nice and low so that the acceleration due to gravity is small, and we see something of a pendulum. It's fastest near A equals 0 and kind of slows down. But because this is a small angle first order approximation, what you'll notice is that it only works for small initial conditions, such as see, that looks kind of realistic. But if you set it to something high, like let's say pi over 2 plus you see that now it loses a certain gravitational appeal, which motivates the suggestion to solve this equation numerically. And we'll begin by doing it with Euler's method. So we note that this is a second order differential equation, and Euler's method is a kind of a fucking slope field first order slope following slope approximation kind of method. And it's not really intuitive what is a second order slope in a two-dimensional plot. So naturally this turns into a system of two differential equations, and what we'll do is we'll call so A1 is theta and A2 is d theta over dt. So then dA1 over dt is then d is a2, and dA2 over dt is conveniently the second order derivative of theta, which is just minus g over L sine theta. So when solving a differential equation numerically using Euler's method, all you do is you set the initial conditions, you set a kind of a step size, which is usually a very small value. These are, of course, algebraic comments until we get a true interface with the Rulliard, but comment the small angle approximation out. And so for the Euler's method structure, we simply do something like this plus h times a2, and then a2 equals a2 plus h times minus g over L sine a1 and our final angle, or our display angle, is our a1, of course. Okay. So here we get something that looks gravitational. It's slow at the top, it's fast here, and then slows at the very top. So if this was 180 degrees or pi, it would not move. But then a very little, let's call this a noise source, should shift it just over. And it does, yeah. You see it slowly accelerate. And it will go back to its very close. We make this a little larger. Or even and we hope that everything we did up to this point is correct. So now let's try a small angle in itself. And you see that for small angles, our Euler's method is rather close. So then if we try, let's call this big A, pi plus 0.5. The fuck? Okay, and you get the point. So the reason I did all of the above was because I wanted to add something of a rope swing mechanic to this dream game, and I've yet to comment on the playthrough, which I might as well do now. So this is the new game, which involves laser puzzles, namely this chaotic scattering mechanism, which is called a Gaspard-Rye system. So in this game you can laser buttons which do things like add more buttons and create these reflectional scenarios. And I think anyway, so to beat this game, what I'm gonna do is avoid this igloo and descend down into the cave, the volcanic cave. And here I can unlock the helicopter, and all I'm gonna do now is fly out of here with the helicopter. You know, we got the helicopter, let's get the fuck out as soon as possible. So we get out of the volcano, out of the cone, and make our way to the so-called checkpoints. And checkpoints are represented by these cell phone towers. And once you cross them, you can press escape and respawn here with your helicopter in place. So from here we'll go down here, we'll grab this sword. And then if we go through here, there's a bunch of enemies which we can kill with a sword. But, you know, let's just respawn. Having the sword. Let's make our way over to the next checkpoint. Past the cone. Right here. And this gives you the machine gun rifle. And here you got some more There's enemies there, but we don't need to deal with them. We can activate this button just for fun. As well as this one. And this button unlocks the castle. And this creates this a long bridge from the previous checkpoint into the castle, as well as that unlocks this latch right here, which is normally closed and there's no way to get inside. So you go down here and we have another, reflector which turns on this button, which then lowers this ladder. And if you go up here, you see that there's this reflector and a bunch of enemies overhead. So we can shoot these enemies like this by being clever about our angles. And we notice that the death ray is shut off when both of these laser buttons are pressed. But then, as we were pressing it, we got killed by the blue Santa, the evil Santa. So the way we're going to handle this is we're going to take the helicopter and fly all the way back. And in this game, these vases give you bonus health. So now, what I'm going to do is I'll go down to the cave, to the ancient ruins, and pick up all the vases. Guess I should do it like this. So we have some stuff here, some vases. We have one here. One here. One here. Here's another cave that's only accessible. And this is a fun little house of mirrors. Which doesn't really do anything because I thought about doing more intricate laser mazes for this game, but I thought that it wouldn't really catch on. So I try to keep it as simple as possible. So we collect these two vases and we notice that our health is at 345, which is quite a lot and enough to defeat the powerful evil Santa. And that's what we're gonna do. Because the machine gun doesn't deal damage as much as the sword, we'll equip the sword and hop on the helicopter and make our way to the castle, which is already opened. Here we'll just get in position, kill him, kill this enemy, and we remember that there is this set of reflectors there that is capable of reaching, due to the phenomenon of chaotic scattering, it's capable of reaching both of these laser buttons, and we see we obtain the victory condition by turning off both this one and that one. So now we took over the personal home built by the looted ruins of the evil Santa. We've turned off the death ray, and we have the helicopter at our... And then we could take out the tower guards here, guarding the antennae and the dipoles. But let's just make sure that... Yeah, no reason to go down here, so... Fuck. So the victory condition is obtained, helicopter obtained. The castle could be cleaned up, but it's not necessary. And that's all there is to it, really. Here's our palace, you know. We've conquered, we've won. Shoot up in celebration. And if you're so curious as to see what's in the castle, we can go down. Here's our big quad reflector. Whatever. And this is a cave which is marked by a couple of signs telling you that if you go down here, you can never get back up. And there is absolutely nothing up ahead. Just a waste of time. So that's that.